Assalamualaikum and hi. My name is Nabihah binti Mohamed Pakarudin.
Hai, Assalamualaikum. My name is Safura binti Mohamed Shakri.
Hi and Assalamualaikum. My name is Sarah Akilah binti Tajir Arifin.
This video will be divided into 4 parts. First, we will start off with introduction. The data used in this project is regarding the occurrence of influenza activity in year 2018 with epidemic week as x-axis and number of cluster which acts as y-axis. The data was obtained from Annual Health Report 2018 which was prepared by the Ministry of Health Malaysia.
Next, I will explain our implementation towards the data in order to find the best fit curve of the data. First, we will start with the linear model. The linear equation for linear model is y equal to a plus bx. Next, we can set up the matrix representation for x and y using mv equal to y. The next section is for the normal equation. Next, we need to find that m and n are the vector of v by multiplying the inverse of A transpose with A and multiply with A transpose times B in order to obtain the least square solution that is 1533 over 442. Another one is negative 1179 over 23,426. After that, we can find the error vector of the data by using the formula E equal to y minus mv, and we will be able to get the error magnitude, or we call it as norm of error vector, that is 181,153 over 23,426. Next to it is equation of best fit curve that we get from the least square solution, which is negative 1,179x over 23,426 plus 1,533 over 442. This is the graph of best fit curve for linear model. The slides shows the graph of residuals that we get, and this is the last part of linear model.
Moving on to quadratic model. For the quadratic model, the matrix representation are as below. The number in matrix K are squared numbers of 1 until 52, which are the total of our data. For matrix Y, it is the number of clusters which remain the same for all model. Shown here are the normal equations. Below are the maple output for least square solution. Shown here are the error vector and its norm. Norm is the square root of the sum of each error vector squared. On the left side, we also have the equation of the best fit curve, which will further be graphically explained in the next slide. Shown here is the quadratic curve and its observed data. Lastly, the graph of residuals, which tells us the difference between the observed response and fitted response values.
Okay, this is the last models that we want to present. The topic of it is cubic models. Okay, for this slide, as you can see, there are two matrix representation in these cubic models, which is matrix M includes the number of x, x squared and x cubed, while for the V is the value of y. Here you can see J with capital letter equals to A plus BJ plus CK plus DK with capital letters, which is this equation actually represent to y equals to A plus bx plus cx squared plus dx cubed. Okay, next, to find the value of A, B, C, and D, we need to use least square methods to solve it, where the formula of it is V equals to the inverse of M transpose M times with M transpose Y. After that, we will get the equation of best fit of the cubic models. Alright, we already have the equation, but how to find the error vector? To find it, you just need to use the formula of y minus with mv. And to normalize it, just magnitude of all the values in the error vector. For this slide, you can see there are two different lines in it, where each line actually has their own meaning. Okay, for the first blue one, it is actually represent for our case data, while the red one is represent for the cubic equation. Alright, this is the last slide in cubic models, which is what you can see is the graph residual of cubic models. Okay, let's move to the next slide. The topic of the next slide is analysis and conclusion.
From the table, we can see the value of error magnitude for each model. The first model, which is linear model, the error magnitude value is 7.732988987. That is quadratic and the value is 6.681008281. And the last one is cubic. And we get the value of error magnitude is 6.527559898. And we get to know that cubic has the least value of error magnitude. So we only stop at cubic best fit curve, as we already found that the cubic is less than linear and quadratic.
Based on what we obtained in the analysis, cubic models have been chosen for the best fit curve. It is because the cubic models have the lowest magnitude of error vector. So, this is why we'll show again the graph of cubic model. Okay, that's all from us. Thank you.